right, using recursive rules with sequences and functions, let's get started. Two types of rules, explicit rules and recursive rules. You might want to jot these down or summarize them. An explicit rule gives a sub n as a function of the term's position, number in the sequence. An explicit rule is what we've been doing, what we've been using. Things like a sub n equals 4n plus 1, or a sub n equals 3 times 4 raised to the n minus 1. Those were explicit rules. Recursive rules, on the other hand, give the beginning term of the sequence, so we need the first term, and then some sort of recursive equation that tells us how we get a sub n. Okay, so it's a little bit more complex. We need two things. We need the first term, and we also need that recursive equation to give us the rest of the terms. I think once you see an example, that'll become a little bit more clear. We want to write the first 6 terms in the sequence. You should write this. You should write this somewhere. A sub n minus 1. That means the term preceding or right before a sub n. I'm going to rewrite a sub 0 equals 1, just so we can kind of keep track of it all there in yellow. Now, if I want to go find a sub 1, that's the next term. So a sub 1 is going to equal, all right, now I'm following my formula here. Okay, better change colors. I'm following my formula. A sub 1 equals a sub n minus 1. Well, 1 minus 1 is a sub 0, right? Because my n is 1 right here in this example.
So that's just 1.
Yes. Yep. You're a little bit ahead of me, Taylor, but yep, you're right. Yep, and then I'm going to add 4 to it. Okay, so this is actually a sub 0 is 1, so 1 plus 4, which is 5. Now let's go find a sub 2, or the third term, a sub 2. Well, a sub 2 equals a sub n minus 1. So 2 minus 1 is a sub 1 plus 4. Convenient, we just figured out what a sub 1 was. It was 5. So this is actually going to be 5 plus 4, which is 9. When you do this in your homework, try and be really organized, and you'll start to see the patterns. Notice that 4 pops up over and over again. Notice that the previous number is always going right here, kind of next to the 4, and you'll start to see patterns pretty quickly, I think. A sub 3 is going to be a sub 2. Yeah. So a sub 3 is a sub 2 plus 4, which we said was 9 plus 4, which is 13. And you guys can see that we're adding 4 every time. This is an arithmetic sequence, and there's 2 ways that we can write it. We can write it explicitly, like we have been, or we can write it recursively, like this, where we give you the first term and then a rule. I'm going to start with a sub 1 equals 1. Now it happens to be that our first term in both examples equaled 1, and we started at 1. That's not always going to be true. You could start at 1/3 or 5 or 15. Now let's go find a sub 2, which is the next term. A sub 2 equals, now if I look at my rule up here, it says 3 times the previous term, or the term right before a sub 2. So this is going to be 3 times a sub 1. Well, we already know a sub 1 is 3 times 1, so that's going to be 3. All right, a sub 3, we're going to do the same thing. Take 3, multiply it by a sub 2. That's going to give me 3 times 3, which is 9. And then we're going to go find a sub 4, which is going to be 3 times a sub 3, which is going to be 3 times 9, which is 27. And you guys can kind of see the pattern that we're multiplying by 3 every time. So this is a geometric sequence that can be written explicitly like we did before, or recursively like we did here. A sub 5 equals 3 times a sub 4, which is going to be 3 times 27, which is 81. Okay, and that number 27 came from here. All right, very quickly here. A sub n equals a sub n minus 1 plus d. If you're looking at a sequence and you're analyzing it and you see that there's a common difference, this is how we would write an arithmetic sequence recursively. Oh no. Sorry. This is by common difference. common diff. Okay, and over here for the geometric sequence, this r is my common ratio. Okay, remembering that a sub n minus 1 is the term right before a sub n. Any questions on these? All right, for number 1, excuse me, the first thing I always check is to see if it's an arithmetic sequence or not. Those are the easiest if you're adding the same thing over and over. And it looks like here I'm adding 10 every time, so my d is 10. All right, so if I'm thinking about my rule, I think all I need is the d, right? It's an arithmetic sequence, so a sub n equals a sub n minus 1 plus 10 plus d. And that's it. I mean, that's the rule that's my rule. That's my recursive rule. If I was to write other terms in the sequence, I would also need the first term, which is 3, but we just want the rule in this example. Write a recursive rule for this sequence. This one clearly is not arithmetic, so I'm going to go check and see if it's geometric. Let's go up to the top here and see if we can't find a common ratio. So to do that, I'm going to take the second term divided by the first term. See what that is. 40 divided by 16. I'll take a decimal, that's fine. 2.5, okay. And then let's take a look at 100 divided by 40. Oh, sweet. 2.5. I think 250 divided by 100 is also 2.5. So our common ratio is 2.5. R equals 2.5. So to write my sequence, a sub n equals, what was that rule?
R times...
Okay, R times...
A sub n minus 1.
Right, we said R was 2.5, so 2.5 times a sub n minus 1. Looking at these sequences that aren't kind of so friendly, we're going to really try and look for patterns here. And it looks like if I want to find, for instance, the third term, I'm going to take 1 plus 1, and that'll give me 2. Okay? If I want to find the next term, I'm going to run out of room here, but 2 plus 1, and that'll give me 3. Okay? So I'm going to erase that because that's a mess. But that's the pattern. Okay? So if I want the next term, it's going to be 5 plus 3, which is 8. And the next term is going to be 5 plus 8, which is 13. And the question is, how do I write this as, a sub n equals, or what is my rule, so I can write this recursively?
Would it be a sub n minus...
We need to know that a sub 1 is 1, and we need to know that a sub 2 is 1 also. If we don't have the first and second terms, there's no way we're going to write a rule. Okay? At least for this example. Let's write the next term generally. So a sub 3. Now you guys know a sub 3 is 2. But didn't we just decide that to find a sub 3, I take 1 plus 1?
Yeah.
And we just said, hey, 1 plus 1, that's a sub 1 plus a sub 2. Is that right?
Yeah.
Okay. So if we were to go find the fourth term, a sub 4 equals what?
A sub 2 plus
A sub 2 plus a
a sub 3.
sub 3. And that pattern is going to repeat. So I want to write that generally. I'm going to look at this and say, all right, a sub n. If I look at the numbers or the subscripts here, when I had a sub 4, I took a sub 2 and then a sub 3. What did I do to 4 to get to 2?
A sub n minus 2.
All right, a sub n minus 2, right? 4 minus 2 gave me 2. And then how did I get from 4 to 3?
A sub n minus 2.
I subtracted 1. So we're going to take and we're going to add a sub n minus 1. And that's going to be my rule. We can check that and make sure that it actually works. Let's take a sub, let's find a sub, I don't know, a sub 8. Okay, a sub 8, that should be a sub 7 plus a sub, oops, excuse me, a sub 6 plus a sub 7. Okay, here we go. That's a z. I'll get it together here, don't worry. A sub 6 plus a sub 7. What was the sixth term? 8. And then what was the seventh term? 13, right? 13. Okay, so that's going to be 21. So I think it checks out. I think it works. Here's your assignment for section 5, page 8, 34 to 8, 14 to 18, 20, and 43. I thought it was pretty nice, a nice and short assignment, so good luck.